So Matthew Hudson will talk to you about the matrix end-to-end encryption.
Thank you very much.
Welcome.
Hi. Can you hear me? Thank you. Can everybody hear me all right? Wonderful. Brilliant. You can ask questions during it if you want, particularly as we tend to run out of time sometimes at the end for questions. Who doesn't know what matrix is? We've got 3, 4, 5 people. 6, 6.5, 7. Okay. Very quickly, I'll try to give a very rushed explanation of matrix. Apologies to people who came to the earlier talk, because it is identical to trying to bring people up to speed. In this, we're going to be talking about how we have made end-to-end encryption on matrix over the last couple of years and how we are finally turning it on by default, like now, and also look at how to break it a bit if we have time. So, matrix, it's an open network for secure, decentralized, real-time communication. Use it for chat, VoIP, VR, AR, IoT. It's basically a big multiplayer pub-sub database. Anybody can store data in it of any kind. They can subscribe to it on other servers. It's meant to be, and it is, the missing communication layer of the web itself. So the whole idea is to have a global open comms network which is standards-based and provides an open platform for real-time comms, just like the web, but for real-time communication. One way to think of it is if you have the silos of the various different proprietary or not proprietary islands of communication today, Matrix can sit in the middle as this big mesh of servers which are replicating conversations between them. They have native Matrix clients here. They have bridges through to other protocols. And so somebody on XMPP could be talking through to somebody on IRC without even realizing that they're being bridged via Matrix in the middle. Lots of people use it natively. Other people go and bridge through to other networks too. The unique thing is that no single person owns your conversations. The conversations are shared over everybody. So if I am on my Matrix server and I want to talk to somebody on another server, the very act of talking to them has almost subversively decentralized the conversation between us. So their copy is just as valid as my copy. It's just like Git. Anybody who's ever pushed or pulled to a Git repository, or cloned one for that matter, should understand what's going on. Architecturally, clients, servers, application servers, identity servers. Identity servers suck. We want to kill them off. Hopefully we will. What do you get in the spec? You get some decentralized conversation history, group messaging as a first-class citizen, obviously end-to-end encryption. That's why we're here, right? So end-to-end encryption, we began in 2015 by implementing Olm as the double ratchet algorithm used by Signal, originally called libaxolotl at the time. We implemented our Apache license version of it. And then we added Megolm the next year in 2016. And since then, we've been chipping away at it, trying to get it to parity with the non-encrypted flavor of Matrix so that we could turn it on by default for private conversations. Worth noting that we're not planning to turn it on by default for public conversations. Because if you are having a conversation that is already being indexed by Google, it's in public, it's like anybody can join it, there is very, very little point to encrypting it. Arguably, you get a little bit of nice properties in terms of deniability or in terms of the signatures to prove that people said these things, but in the end, it also has scalability issues. We have rooms of Matrix with over 100,000 users in them. Each user averages about 2 or 3 devices, so that's 300,000 endpoints, and we're focused at the moment of making Matrix kick ass for private encrypted rooms with a couple of thousand devices rather than 300,000. Also, VoIP signaling, server-side goodies, unread counts, all the stuff that you expect to get from a modern communication app like WhatsApp or Slack or Discord. Ecosystem, you have the spec, you have the servers, the bridges, the application servers, and then you have the clients. Worth noting that Riot X here is almost at the point of replacing Riot Android. We're entering the 1.0 release basically now, with release candidates on the horizon over the coming weeks. I think we just shipped Riot X 14.1, or is it .2, Benoit? 2. And that is hopefully one of the last builds before we go GA 1.0. So if you're not using Riot X on Android, please give it a whirl, particularly as it has a lot of the end-to-end encryption goodies in it, which we're talking about today. I've started using it on Android in the last couple of days, mainly because there was a double free crash that was killing my account on it, but now that's fixed. It's really nice, like unrecognizably better than Riot Android. terms of uptake, daily active users are following this interesting parabola over the last 3 years. Not much really to say about that, other than it puts a lot of pressure on us to make sure that the server implementations scale. And overall community stats of 13 mil global MX IDs, about 5 million messages a day that we can see, 4.5 million chat rooms that we can see from matrix.org, 20,000 servers, actually 40,000 in the real world, 3,500 messages a second going out, about 35 hertz coming in, and lots of different companies, projects, and also governments building on top of Matrix, most famously France, also Germany as of the end of last year. The US has some servers as well, and we're working with the UK as well. If anybody owns a government around here and wants to get them on Matrix, please come and talk to me afterwards, because it's kind of fun to get all the different countries on the same encrypted comms and infrastructure. So, sorry for the boring bit. Let's get on with the fun stuff. Finishing E2E in Matrix. First of all, E2E by default is obviously really important for various different reasons. First of all, we're replicating conversations everywhere in Matrix in the first place, and so every server that joins a room gets a copy of that data. If it's not end-to-end encrypted, your attack surface just scales linearly, and that is obviously bad news. Also, we want to protect ourselves from compromised servers in general. That might be malicious sysadmins, it might be people who've compromised a given server. We also want to be protected by people who've man-in-the-middle the TLS. End-to-end encryption is also useful because it asserts the sender identity, and it also gives us a framework for verifying users' keys and verifying their identity. And we actually started this whole final leg of turning on E2E by default at 2019 last year. So here's a flashback, actually of a flashback. This is a meta flashback of a slide from FOSDEM in 2017, where we said, this is what we need to do in the next couple of years to get E2E turned on. And as of 2019, we got that far physically down that list. We were literally going through it in turn. The only things we lacked were E2E capable search, actually turning it on, obviously, negotiating it with legacy clients, and in retrospect, we kind of had a few other things. We need to support non-E2E clients. We do not want every random hacker who's written a Matrix client or bot to be left out in the cold because they can no longer get at their DMs or their private rooms because we've turned on E2E by default. We want to obviously be able to search. We want to have file indexes. Really nice to have your file panel in right to show you what's in a room. You need to finalize the UI UX. Cross-signing, absolutely critical, as everybody in this room knows, apart from 7, it's really annoying in Matrix when somebody joins the conversation with a new device because you have to verify it. What if they could attest to their own device, so you verify a user once and you don't have to keep verifying their other devices? And finally, even better verification UX, so not just the overall UX, but specifically making this as easy and smooth as possible. So, in turn, Pantalaemon. Who knows what Pantalaemon is? Okay, about half the room. So Pantalaemon is obviously Lyra's daemon from his Dark Materials. Also, it's an end-to-end encrypted daemon that offloads all of your E2E. So the idea is that if you're writing some random little Matrix throwaway script or new client and you can't be bothered to write an audited, massive, complicated E2E implementation, you can just connect via Matrix to a local daemon that offloads all the hard stuff and it proxies you through to your actual server. It's written in Python, in async IO using the no IO style, which is basically you abstract all the IO away and then plug it into async IO at the last minute. It provides management interface by dbus, and we ship a command line interface, but the idea is that people will hopefully write little system tray pop-ups, so you can have little things here saying, hey, do you want to verify the new user in this conversation, even when you're not using an E2E capable client. It's actually the same stack as WeChat Matrix. It's written by a chap called Damir, whose nick is Polya on Matrix, who originally was doing WeChat Matrix, and it was really, really cool. He wrote his own Python implementation of E2E and an entire Matrix SDK, and so he said, hey, Damir, why not come and work on Matrix full-time and come and work on Pantalaemon? So that is where Pantalaemon has come from, and most excitingly, and I didn't ask his permission to reveal this, but it's the case, if you look on GitHub, that he's busy rewriting, first of all, WeChat Matrix in Rust, using Rumor as the client framework and structures. And also, we're using Olm RS, which is the native Rust implementation of Olm that has come from the Fractal developer community. Huge thanks to Brain Blasted, and Johannes Hayes for relicensing, and the other contributors for relicensing OMRS so that we could use it in the Apache stack of all of the official Matrix projects. And the idea is to build an official Matrix Rust SDK on top of this stack that can be used in Pantalaemon in future and other clients. So that's Pantalaemon. Let me quickly show you it. Risk a live demo. You know how well these are going today. So here is Pantalaemon, just sitting here in the background. It's going and decrypting syncs. It's going and sending device messages around the place. And you might wonder, what is connected to it? Well, this client here is what is connected to it. Anybody know what this is? One person does. 2, 3, 4. So this is a really interesting client. It might look very minimal because there is no UI on it really at all. But it's called Brawl. It's written by Bruno, who's one of Riot web developers, and it's an experiment in an entirely new JS SDK. This is backed by IndexedDB in a really intelligent way, unlike JS SDK, which predated the existence of IndexedDB. And he's experimenting with it as a spare time project, just to see how nice a JS SDK you can build, such that we might eventually use it in Riot Web or similar. And this room here is talking through to me is at matthew.matrix.org, and if I say, hello, Matthew, it goes and sends, and you can see that it's been sent there. And I go through to here, and you can see a hello, Matthew coming in here. And the key thing is that, as you can see, for our new UX, this room is actually end-to-end encrypted with the shield here. I haven't verified Matthew's test 7. I can respond back with hello, and assuming I have enough connectivity, and if the matrix.org server is working, yay, there you go, you get the hello, yay, coming back. So that is basically what it looks like. You've got an experimental client, you haven't bothered with E2E, you pipe it through Pantalaemon, hey presto, it's all E2E. And I haven't actually tested this, so probably will go horribly wrong, but if I were to go into here and try to verify Matthew 7 test and start verification, you can actually see our new UI that is coming together for verification requests. I have a horrible feeling that it's going to try to do this via cross-signing Voodoo and not actually make it through to Pantalaemon. It hasn't. But basically, Pantalaemon does support verification pre-cross-signing, and obviously in the near future, it will support cross-signing too. So that's Pantalaemon. So that's one of the big missing ingredients. Now done. It's stable. We use it in production. Lots of random bots in encrypted rooms, particularly for kind of managing the matrix.org home server, where we want to pull in a bot, we just wedge it through Pantalaemon so it can be in the encrypted room. Seshat, also actually done by Demir, entirely new solution to full text search. Obviously, if you're end-to-end encrypting your chat rooms, you can't search server-side on the encrypted messages unless you do very exotic things with homomorphic encryption that we don't have time to figure out right now. So what we did instead was to take Tantivy, which is a Rust full-text search engine, very similar to Lucene, except much, much, much smaller and written in Rust rather than Java or whatever Lucene is written in today. And what we've done is to compile it client-side, and here it is, basically as a bunch of Rust wrapped in a node wrapper, and then we have Matrix Seshat as JavaScript bindings on top of this, which means that we can then embed it into the Matrix React SDK and in turn into Riot Web. And what Tantivy does and Seshat does is to spider all of your messages from your encrypted accounts and build up a full text search index of it all. So interesting things that we can do with Seshat is that it's cross-platform in Rust. So we could easily integrate it in other clients, not just Riot, but any Matrix client can use this in future. We can also potentially incrementally gossip the encrypted indexes between each other. And a really fun thing we've done is to pipe all of the data through SQL Cipher before storing it in SQLite, as well as adding encryption support to Tantivy, so that it's literally decrypting your E2E history, indexing it, and then storing it to disk locally as in turn encrypted messages. And that in turn could be gossip between different clients, so you can leave your laptop on Riot Desktop going and spidering away all of your messages, building up these indexes, and meanwhile you log on a phone, and all it has to do is to perhaps lazy load the indexes on a per room basis, and it doesn't have to re-index everything. It can just pick up the index that has been pre-calculated. So this is shipped now in the develop branch of Riot Desktop. The only catch is we need to finish updating our build infrastructure to do Rust native modules on Riot Desktop. We don't yet have it in Riot Web because WASM doesn't support threads, and tentatively is very heavily threaded, so we can't compile it down to WASM yet. In terms of what it looks like, if I go to some encrypted room, which I probably should have picked beforehand, New Vector Limited is where the UK office of New Vector working on Matrix decide where to go for lunch mainly and tell each other about caramel and brownie bites. But if I go and search an encrypted room like this now and search for, I don't know, Duke, which is our local pub, apparently we haven't been talking about the Duke. No, sorry, here, I'm on Riot Web. I should be on Riot Desktop. Let me go and just set that going. Not yarn install, yarn run electron. Let me go and fire up Riot Desktop. So that's what it looks like today. A few minutes, we'll come back to that, and we can look at how it works in Electron. Right, what next? Another big thing that was blocking us, unashamedly, is that we've been plagued by these undecryptable messages. And it's got better over the years, I hope everybody will agree. Yeah, well, that's Electron. However, it's still a bit of a pain in the ass that there are scenarios where you can just get messages and you don't have the keys to decrypt them. So, I mean, the core problem about this is architecturally today, keys follow a different transport path than the messages. In Matrix, the messages can be replicated everywhere, and you can indirectly get them from random servers, and you can have 10 servers in the room, and all of them can go down apart from one, and you'll still get the messages because that server has the messages. However, that is not the path that keys take. And if you think about it, it's possibly a bit distasteful that just because I'm trying to set up a one-to-one encrypted channel with somebody on their server between theirs and mine, why should that get relayed and flooded across all the other servers in a room? It's very inefficient. It would be basically ON squared, irrelevant signaling clutter. So, two solutions. We could go and somehow attach it into the DAG anyway, so it does cover the same path, but it would flood lots and lots of information everywhere needlessly and slow everything down even more. Or we could switch tack entirely, do something a bit like MLS, where you just have a totally different algorithm for distributing keys. In MLS, you distribute them over a tree of the devices in a room, effectively, rather than a full mesh. However, short term, in practice, unavoidable key distribution fails where you've had, say, a net split and a device has joined a room on one side of a net split and you just can't see it, and so you're never going to send it the key because you didn't know it existed. That sort of unavoidable thing is pretty unlikely, and meanwhile we did find a whole bunch of other bugs which were causing failures. So in the short term, to get E2E turned on by default, what we've done is to go through the list of the avoidable failures and try to fix them. And it's mainly around keeping track of what devices are present in a room so that you know who to encrypt for. And everybody knows that there are 3 hard problems in computer science of cache invalidation, off-by-1 errors. And the idea, I guess, is that here, they're all different classes of cache invalidation problems, that your server knows what devices it thinks are in a room. It needs to replicate that data with other ones. So we now flush the device lists a lot more aggressively. If we do discover a cache fail or an integrity fail, and somebody sends us a message from a device we've never heard of before, rather than panicking, we say, well, hang on, tell us about that device. And so we've got a whole bunch of recovery mechanisms in there now. Also, after a federation outage, there was a class of failures where device links would not recover properly. I think our record so far has been 3 years of a server that came back and couldn't encrypt messages for me or Amandine, and it turned out that it had got out of sync 3 years ago and never recovered. All of these are now hopefully fixed, and they are in the release candidate for 1.10 that we went and cut on Friday and should ship in 1.10 final in probably early next week. We've also improved things a lot around the unavoidable failures. Turns out that one of the most popular reasons for getting an undecryptable message in Matrix is somebody had blacklisted you. And you couldn't tell because it was the same, oh, you don't have the keys. And everybody said, oh, Matrix is terrible because I didn't get the keys. Well, it turns out it's because the sender explicitly said, don't send him the keys. So we've now gone and actually put that in the UI. Also telling the user various different paths, basically. If the sender didn't know the client existed, then we tell the receiver that was what happened. If the OLM session has got wedged because of weird corruption, we tell them to. We're getting rid of the useless, scary replay attack, duplicate message things, which just meant it was a duplicate message. And also hiding the useless unencryptable messages that predate you joining the room. All of that good stuff should ship in Riot Web 1.6, which happens again in the next week or so. So cross-signing. Cross-signing has been an absolute epic. The whole point is to let users vouch for their own devices so you don't have to verify everybody individually every time they dare to log into a new device on their account. And we did a very early demo last year, which was winged together at the last minute to give a taste of how this could look. And it was built on Matrix spec change 1680, which was just called cross-signing. And this is a really cool idea. If you look at the spec, it's basically the idea that any device can sign any other device. It's a bit like PGP. Anybody can sign anybody else's key. You end up with a great big DAG, at least of the user's own devices. And that's what we implemented. However, it suddenly became clear that it was a bit too complicated. Alice's device A could sign her device B, and then her device B could sign C. C signs A, you got a loop. What happens if B gets lost? You end up kind of with a fragmented net splitted trust graph, and what the hell do you do next? Also, there was just no central way for a user as a person to just manage that mess, which is basically the same problem. It ends up getting fragmented. So MSE 1680 got retired. Starting over, now MSE 1756, now called cross-signing with device signing keys. Now this is a massive change to Matrix. For the first time, we have a per-user key. It's no longer per-device keys. In fact, we have 3 of them. We have the one that you use to sign your own devices, you have the one that you use to sign other people's devices, and you have the master key that goes and signs both of those. We've gone and split them up just for hygiene because they do different things. It allows you to rotate them separately, particularly useful to basically have different trust levels for the different keys. Signatures get stored on your home server. We only expose them to users that they relate to, so this is not a big web of trust. This is a personal web of trust for your devices and the people that you have signed. Practically speaking, looks like that. A for Alice has got a master key. She's got a self-signing key and a user signing key. With her user signing key, she's signed Bob's master key. Bob's master key in turn has signed Bob's self-signing key and his user signing key. And Bob has a Dynabook and a VAX, which is signed off on. Alice has a PDP-11, not to be confused with a VAX, and Osborne 2. And most importantly, Bob is also mutually verified back to Alice. So that's the data structure that we have going on the server. We also need a way, though, to synchronize these keys between devices. And we could gossip between them, or we can store them encrypted, of course, on the server. And this is really very similar to how we handled key backups today. If you've got all of your E2E keys, what do you do? Do you store them encrypted on the server, or do you go and gossip them key sharing between the different devices? So we're doing both. It's called MSC 1946. Always weird how these line up with like years. And it's called QuadS, Secure Secret Storage and Sharing. And it works by storing your secrets and your account data. Ancient Matrix API for storing arbitrary data about yourself. And you can also use it for sharing directly via 2 devices between trusted devices. And I'm afraid it is yet another key. This time it really is the master key. It's your QuadS master key. Single most important one. It replaces the old backup recovery key and passphrase. And in fact, when you turn on cross-signing, the first thing it will do is to migrate or bootstrap your old backup key and instead replace it by the master key, which now signs the backup key. So very similar to key backup, the private half should be stored somewhere secure, offline, in a trusted, protected part of your OS if you have one. You only need to ever provide it when you log into new secrets. Or you go and use it to sign with somebody. And this is actually a bit of an annoyance in some ways right now, in that whenever you need to unlock your master secrets in order to write to it, you do need to provide that private key. Well, we're looking at ways to improve this. So this is particularly annoying on Riot Web because you don't have a safe place to store private keys. So right now we are prompting every time it needs for you to enter your passphrase in order to go and sign somebody or to log into a new device. On the UX side, we've made a fundamental change. We've shifted to using shields to try to describe trust. And we basically have 3 different classes here. We've got unknown trust, which is a black shield. It means it's encrypted, but you have no reason to particularly trust or distrust any devices. Then separately, you've got the red shield, untrusted, which means that you went and explicitly verified somebody in that room, but they have now gone and added in a device which is not trusted. So they're probably being owned. This is bad news. And then finally, trusted, which is green, which means that you have not only trusted the user, but they or you have trusted all of their devices, and so you know for sure that they are in control of all of their devices. The UX has been an epic. This is Nad's wireframes in Figma for, not even wireframes, the actual assets in Figma for the whole enchilada. If we zoom in just one little bit of it, you can see all the various flows being designed there. Sorry for all of the ugly mugshots on Android and iOS. And we basically have really professionally gone through analyzing and designing all of the cross-signing flows that we can. This has been implemented in RiotX. It's also landed in test flight on iOS, in the majority of it at least, and apart from QR scanning, which I'll come to in a minute. And it's also there on Riot Web Develop. Hopefully, people will all agree it's a massive step up on the UX and visuals from what we've had before. Finally, better verification. We're introducing QR codes as well as emoji. This is not killing off emoji. We love the emoji verification, but sometimes it's easier to go bloop than go tango, whatever, call out emojis to one another. The way it works is that you basically produce a QR code with all of the keys you want to verify on it. It's not an interactive thing at the moment, so it's actually quite a complicated QR code because it has a lot of public keys in it. And you show it to the other person. If it matches their copy of it, then they go and handshake back and say, yep, I trust that QR code. And we do this, quite importantly, we do this both in-band and out-of-band, which allows us to mutually verify the other person. That if we see them physically say, yeah, my phone says that that QR code is right, and you talk about that in person, then you've already taken out any malicious man in the middle and can say, well, okay, I better trust it on my side too. So it's a single QR scan to mutually verify Alice and Bob with respect to one another. Another big change is that, as you saw briefly earlier, verification flows are now in your DM. They're not random modals that pop up and annoy you. Instead, they are actually in the timeline of the person that you're talking to. So what blocked us? Lots of things. However, they're now all solved. So it's now enabled, as I said, on Riot Web Develop, Riot X, and Riot iOS. Shall we actually try to demo it and see how well this goes? So here is one that there's Brawl. Ooh, here's one that I made earlier. This is already logged on as a user called Bob, B for Bob. Let me fire up a new incognito window on a different port or different address and see what it looks like to sign up for the first time in this brave new world. So I'm going to create an account on my personal server. This Bob is called, let me see, Bob10, so I'm going to create Alice10 with a secret password. And totally new UI flow already. This is now setting up the SSSS master passphrase. So looks and feels a bit like the old flow, and it gives you your recovery key to download or copy. I'll go and download it. And this is now the thing that wraps both your E2E backup keys as well as the cross-signing keys. I go and set up the keys there, and I'm done. My Quad S storage is now set up. I've already done this on Bob's side. Let me go and try to start a chat with Bob10 on arisphere.net. There he is. And hopefully in comes a DM from Alice. You start chatting, and everybody notice that end-to-end encryption is enabled by default, so I do not have to do anything. So, obviously, I haven't trusted Alice yet, so she's coming up with black shield, and likewise Bob and isn't trusting Alice. So let's go into here and start off with a plain old verification. Alice obviously trusts herself, which is reassuring. And this is the new UI for Bob, for verifying Bob. You can go and verify there, hit start verification like so. And look, entirely new UI. We've got the verification coming in the timeline here. We've also got a toaster pop-up thing in the top left. Let me go over here and accept it. And here are our funky new QR codes. Now, I'm going to have problems trying to scan my right web from my right web with my right web without a mirror, and in practice we haven't implemented the webcam scanning yet on right web. So I'm going to fall back, like the good old days, to verifying by emoji. And hey presto, we've got Cloud Dog Panda, blah, 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 blah. I'm going to say it matches, and matches here. And now this is the thing I was mentioning earlier, where you have to enter your master passphrase at this point, on right web at least, to go and persist the data well, basically to persist it encrypted on the server without storing this passphrase and caching it around the place locally. So let me do that. And hey presto, Alice and Bob now trust each other. Now, so far, it's not that exciting because there's only one device on Bob and Alice's side. And if we click on the one verified session, we can say, hey, yeah, there's one on Chrome there, there's another on Chrome there. What would be really fun is if we fired up Riot X. So hopefully, I got a Riot X sitting about here somewhere. Where has it gone? Not Telegram, that's the wrong one. So here is Riot X. Going to get started. Bear with me whilst I go and log on. And if you haven't seen the registration flows, by the way, on Riot X, it's lovely. I'm going to try to remember how to use Android. Talk amongst yourselves briefly. I'm going to try to get onto Arisphere. I'm going to log in as Alice 10, so the left-hand user here. Good job I'm logged out of WhatsApp. Alice 10, a top secret password, and hopefully, welcome to the beta, verify the session. Now, new UI on Alice's side. We've got an unverified device coming in. I'm going to hit verify here on Android, and I'm going to say, well, hang on a second, is that me? I want to review it now. And it says, oh, okay, I can basically grant this, I can verify the new login. I go and click OK, and up comes the QR code. And Android, you can do it either way. So Android's giving a QR code that we could scan if we were doing Riot X to Riot X. In practice, I'm going to hit scan the code here, give Riot X access to do its thing. Up comes the QR code, put that there, and done. That was it. So the really, really exciting thing is that if we go and look at Alice's devices here, there are now 2 verified devices. That's not so surprising because I just self-verified myself. But hopefully, if I go and look on this side, yep, Bob can see both devices cross-signed with one another. So we've got the mobile thing here as well as the web. So cross-signing is here. It's pretty young. We finished it in the bar at the hotel at about 2 a.m. and there may still be some minor issues to be resolved on it. The most obvious ones are that you really want to initiate cross-signing from Riot Web. That's because we haven't implemented SSSS on mobile yet. So whilst you can participate in cross-signing, you can't store the data on the server. So you end up with a slightly brain-damaged world where the device builds up a local store, even though it still trusts things which are being advertised. Also, irritatingly, it turns out we've got a minor bug on Federation that means if you cross-sign across servers, there's some bug we haven't found yet. It'll be fixed in the next couple of days. So that is where things are at right now. Let me just show you one other quick thing, which is to go back to my real account, if I can find it. And I was going to try to show that this isn't snake oil by going to Nad, who designed all of the UX like a year ago on this, and it's taken us all year to implement it and vaguely get it to work. And I haven't verified him yet. And so I'm going to actually risk going and hitting the verify button for real on matrix.org, hit the start verification button, and hopefully on right X. Now do you have it? Oh, there you are. Hopefully it's going to get his verification request coming in.
A little bit of lag.
Yep, there it is.
Oh no.
Accept. Accept. Please accept me. There we go. So, yep, there it is. And go and scan the thing. Come on, you can do it. The camera refusing to focus on the QR code because it's a live demo.
Should we do emoji?
No, the problem is it's oversaturated. If we go and do that. Your camera sucks.
Right, a big screen.
Yeah, perhaps you should. It's so going to end up with me breaking my neck going backwards off this. Come on, you can do it. I don't know. What phone is this? Okay, as we said, the QR code is quite complicated at the moment because it has all of those public keys sitting in it. And we're going to probably provide an alternative that basically takes the emoji and puts them in it, which would be a lot smaller, but it means that you have to go back and forth a couple of times. But I'm going to blame your phone. Clear the lens. Okay, that was it for the cross-signing demo. I've got, 2 minutes or something to try to show how to break this, which is going to be ambitious, so I might just talk even faster. Apologies. Breaking matrix. Our threat model basically went for it earlier. We want to protect our data as well as we can. We want deniability and protection from replay attacks. We don't protect compromised clients. We don't protect metadata yet, but if you came to the P2P talk earlier, you'll have seen that we're working on doing that by moving to the service client side. We don't give you perfect forward secrecy unless you really want it, because in practice it's useful to get at your history on a new device. Sure, it means attackers can also get at your history, but in practice it's more useful to have a Slack or WhatsApp style experience where you can still get at your, not WhatsApp, Slack or Telegram style experience where you can get at your history. You also don't get transcript consistency currently, which is not generally a massive concern, but the decentralized nature of Matrix means that it's okay for different people to have different views of a room because of a net split. So that could possibly be exploited by people like deliberately taking messages out of context, but it comes with the territory at the moment. So lots of ways we could attack this. We could man in the middle of the CS API, we could steal an access token, we can try to add ghost devices and try to get them trusted, so fake devices. We could try to add malicious backups, which is quite an interesting attack vector, given we have these E2E backups. A malicious sysadmin could say, yeah, of course you can trust me to go and back up all your MegaOM keys onto my backup. You can try to exfiltrate the keys from the clients. I have a whole bunch of demos, which I now don't have any time to show you, but it was basically running MITM proxy as an example with a bad CA to intercept all of your HTTPS traffic and start stealing access tokens. And the reality is that you can see the metadata for sure. You can steal an access token, but without the OLM keys from the device, you're fine. You could also try to steal the password and hijack, which could be useful for social engineering verification. And that's probably the nastiest attack that we have there at the moment. We're looking at doing what we call cryptographic login, where rather than passing the password in plain text, in TLS obviously, over the CS API, you instead sign something with your private key, probably your SSSS private key. But we haven't done that yet, mainly because it would be really complicated for developers, whereas today it's quite nice that you just post your username and password and you're in. We'll probably support both, though, so secure clients can do the more secure approach. Adding ghost devices, a compromised server can start creating devices. And we just saw with cross-signing that it should all come up as a big, scary red shield. You can try to then social engineer people and say, don't worry about verifying out of band, just go and tell me the emoji or send me a picture of the QR code and it will be fine. So there's always a risk of social engineering attacks within that to force the malicious device to be verified. And a really interesting one that I've been obsessed with, much to everyone's annoyance, has been shoulder surfing the QR code. Whilst I was messing around trying to scan that code, what if a malicious sysadmin in the room who has compromised my server is also scanning the QR code and saying, no, wait, absolutely, they would have to inject a malicious device so that you're actually scanning a different device to the one that you thought you were verifying, and you would need to go and send the kind of the message back to the other guy that you've scanned that code. In practice, we mitigate this by doing the out-of-band verification as well as the in-band verification that it was them that scanned the code. So every time in future you scan somebody on QR and it says, did you actually scan the right person? It's really important that you do look at the other person's phone and see whether it's got a big green shield on it before you say, yes, of course I signed the person I thought I was signing. What else? Ghost backups, we sign them with the creator's own signing key and only trust them if we trust that device. So backup trust uses the same trust model that we have elsewhere. Exfiltrating keys, probably the worst attack here is brute forcing the passphrase on the server. So if you're worried about that, either make sure you use secure passphrases, and we're looking at ways to enforce it in the client, or just don't use it. You could also try to exfiltrate the message keys. You really should be using protected storage, but if there isn't protected storage, like there basically isn't on the web platform, then in the end, if you have an XSS and somebody steals the keys, you're screwed. Game over. Obviously, the famous XKCD is all very well going on about these amazing attacks and complicated vulnerabilities, but in practice, the likelihood is that somebody's going to hit you with a wrench until they tell you, you tell them the password. MLS, we're experimenting with it. If you don't know what MLS is, go check it out. Decentralized MLS is a variation that we're playing with where we go and decentralize the current centralized sequencing function so that it works with Matrix. It's very early days. It looks promising. It could be revolutionary in terms of shifting the linear complexity to the logarithmic complexity that you get with MLS. Other stuff, metadata, mentioned that. What's next? Riot X 1.0 coming up real soon now. First-time user experience on Riot Web is our big thing in the coming months because we've spent a lot of time focusing on E2E. Now we need to get the rest of the app looking as sexy as the new E2E flows. Communities have to be reworked. That's next on the list after that. And then a whole bunch of other things. Probably the most exciting is the P2P work. Also, Dendrite development is running again. One of the original Dendrite developers, Keegan, has come back to work full-time on Matrix as of last week, and so we should see both work from him and other folks in the P2P world. Also, reputation work has to be done, otherwise we're going to have really interesting social problems like Twitter does today going forwards. And that's it. Thank you.
Thank you, Matthew. I hope NSA is scared. So now Q&A, please again. If you want to exit, crawl very silently, or just better stay in places. And one person, one question, and please raise your hands in advance. So yeah, I will move around, and I will start from.
Hi, first of all, I want to thank you very much for all of your hard work on this, and it's amazing software, and it's come so far. I've watched it evolve, and it's just amazing. But I was curious, as just as kind of a question about, like all this cross-signing stuff is absolutely wonderful. I was wondering if you had any thoughts about the admin user of a Synapse instance being able to pre-verify devices. So, for example, like in an organization or something, if you have company-provided devices, if you could have the admin user be the only trusted user and sign devices on a device-by-device basis.
Yeah, for sure. Well, first of all, thank you for kind words about it. And I should say also thank you to the whole Matrix team who have been killing themselves trying to get this thing out the door. I've had very little to do with basically any of this other than writing some slides at the end of it and screwing up the demos. So thanks to the Matrix guys. In terms of the actual question, yes, we designed the use case where, as a special case, you can have a very limited web of trust, where if you want to delegate your trust to some other user, like a sysadmin, admin who's provisioned your device, then you would, at the protocol level today, be able to sign, or they would be able to sign off on you, and if you chose to sign them, rather than having to manually do it, you'll be able to do that. It's a bit of an edge case. We don't have it in the UX today. You saw what a nightmare the UX is to get right just for the kind of simple flows without also having, oh, now we've got a new class of user who can sign off on people. But from an enterprise and also a government perspective, I'm sure you can imagine that France, who have been end-to-end encrypted since April of last year, are quite interested in the idea where when you onboard somebody into a company or department, there's just one person who is trusted to go zip with the QR code rather than everybody having to, it'd be a fun thing socially to do. Got to meet everybody in the company to kind of verify, but not always practical if you're 5.5 million public sector employees in France.
Hey, so you mentioned the really sensitive quad S key. What kind of key is that, and is there the potential to store that on a smart card or a YubiKey in the future? So
it's a Curve 25519 key pair, and the private side of it could absolutely be stored somewhere safe. One of the reasons we haven't implemented SSSS on mobile is that we want to do it right. We don't want to just chuck the private key on the file system. We want to integrate with whatever the correct latest Android and iOS secure APIs are, so that you have to do Face ID or Touch ID or whatever to get at it. And the next step beyond that would be to integrate with, is it web authentication or whatever the web APIs are, so you can put it down onto a smart card or a tracer or whatever you're playing with. So yeah, we want to, but this is pretty new.
Thank you so much for working on the user experience for secure messaging. It's such a hard thing to get right. And in the free world, we've struggled with this for so long. My question is sort of similar. What are your thoughts about separating the UX for the master key versus the master key or the quad S key?
Yeah, well, as you kind of saw, the only UX exposed to the user here is the top of the pyramid. It's the master quad S key. Previously, it was the next level below, the backup key. But when you upgrade an existing account to use this, there is a bootstrapping flow, which is basically, hey, you need to enter your passphrase again, and then you never see the UX for the next layer down. But you're so right that we were idiots, honestly. Back in 2015, when we first announced this, and we'd gone and got it audited, and we got Ohm and Mega, we've done the cryptography, how hard can this be? And it turns out that it's 98% UX and 2% cryptography, and nobody seems to literally spell it out that literally. But big kudos to Ned for having an amazing smartphone, and also for going through the nightmare of designing the UX for it.
Hey, thanks to you and the Matrix team for making Matrix, and especially for the cross-signing, because I've been waiting for that for years. So my question is particularly related to the unable to decrypt messages. I saw that in 1.10 you're going to be hiding messages sent before the person joined the room. Mm-hmm. But there is a common use case, which is normally, at least before, you would turn on end-to-end encryption, and then you'll say, hey, I turned on encryption, how's everything, what you're doing? But the thing is, the person hasn't joined the room yet. Yep. So those messages are all unable to decrypt. And now that it's enabled by default, if I say, hey, they're not going to be able to read that message because they're not already in here.
So in theory, that should work for the last year or so, because I wrote it. In practice, people sometimes ask this question, which makes me wonder whether it doesn't work. Certainly for the first couple of years of Matrix, it was a very common failure mode. You'd DM somebody, turn on encryption, send some messages, they'd join, and they'd say, huh? And you'd have to copy-paste it and look awful. It really, really upset me to the extent that I went and got into the depths of Synapse, and basically it tries to preemptively share your keys when you invite somebody rather than when they join. There are a couple of edge cases which can go a bit wrong because basically, if the person's on another server, you don't know, and they're not in any rooms on your server, you don't know what devices they have. So you can snapshot it, but there's no reason why they should continue to send you device stuff until they've actually joined a room. Otherwise, you have a DOS vector where I could invite everybody in this room to my random server, and they wouldn't have to accept the invite. Just the act of inviting would be enough to get them to start telling me all of their device data. And on the plus side, it means I can encrypt messages for all of those people, whether they want it or not. But in practice, I might wait for them to join. So basically, it should work. If it doesn't, it's worth filing a bug, and I'll go and try to work out what I did wrong. Okay, yeah, so you might have hit that edge case. Honestly, to fix that, we probably need to fix how device-less synchronization works entirely. It's back to the original problem that I was talking about as the fundamental megon problem, that the device list data and the key replication doesn't follow the path of the messages. So you can end up with messages that have gone somewhere, but the keys haven't got there yet.
Hi. Thank you for your work, and you mentioned in the beginning that metrics, or one of the main goals of metrics is bridging together different protocols, and coming from the XMPP community, I'm also very interested in that, but that kind of is an orthogonal goal to end-to-end encryption.
Sure is.
And so I'm wondering if, do you have plans on cross-protocol end-to-end encryption, like I think MLS kind of touched on that with the Federation document in the workgroup, but are there plans to, I don't know, have like a common message format protocol that you can use to send rich content messages from XMPP to metrics, for example?
So at the cryptographic layer, we absolutely want to be speaking the same language as everybody else. That's why we implemented Olm as a clone of libsignal protocol, so that we were speaking the same thing that Amemo was, that Signal, WhatsApp, Skype, all these different projects had adopted the same cryptographic layer. But the problem is the application layer on top is completely orthogonal to the crypto transport beneath it. And so it's all very well speaking the same dialect of the sort of line, almost the transport layer, or obviously the message layer security in the case of MLS. Whereas in practice, you're going to need to either convert between XMPP stanzas and matrix events and the totally different semantics of the two different protocols, or you have a multi-headed approach effectively where the client needs to speak both, which is feeling increasingly icky. So our solution to this is to look at client-side bridging, and it's something that the P2P stuff really helps us towards. That it's not quite multi-head client, well, it's not a multi-head messenger like Game or whatever Game's called nowadays, Trillion or whatever. Instead, it's that you'd have your matrix client sitting there, and if you want to run a Bifrost, which is our matrix to XMPP bridge, and you want to run it locally on the laptop or even on your phone, then you can plug these relatively lightweight bridges in locally, and it will go and encrypt over matrix, or it will talk XMPP natively out from that, keeping the encryption intact. So we've been playing with it a bit, and there are people who are actually looking at doing this quite seriously. And we also want to federate as well as we can, we'll bridge, I should say, as well as we can with XMPP, and at least have the clear text re-encryption domain under the user's control, rather than some horrific bridge in the sky somewhere, which is reading everyone's traffic.
Hi.
Hello.
Thanks for the amazing work and initiative being done on Matrix. My question is, how is the user experience going to be for revoking or untrusting other devices?
An eagle flying up there.
Yeah, different devices from your own account that you don't recognize anymore as being secure. And then what happens if the network partitions? Is the remote server going to continue encrypting, well, the remote clients?
Yeah. Yeah. Excellent question. So basically, where is the untrust button on the UI? And the fact is that we haven't implemented it on the new UI. We had it on the old UI, and there's literally a bug that we still have unsolved and will stop us. It's a release blocker before we actually push this out of all the developed ones that we cut yesterday. In terms of how that works with federation, well, that's more of a philosophical question. I mean, this is a causality thing. If a tree gets unverified in the woods and no one is there to see it, did it really get unverified? I mean, likewise, if there's a net split and I happen to have verified myself here and you physically can't see it because you're not physically connected to me, I'm sorry, but Matrix is amazing, but we haven't quite solved that causality problem yet. Although I'm working on it in VR with ping pong, but that's an entirely different story.
Hi. It's kind of going further on the question about an admin signing people in the room. Could you have like degrees of trust based on how many people that you trust someone new?
The reason we haven't done that is because of the metadata leak. You start to build a social graph. You start to build a PGP-style web of trust. And if you ever looked at the PGP web of trust, A, it's terrifying because there are so many completely weird bot-like things which have never verified anybody in it, and the rest of it is terrifying because it's a really direct social graph of every human on the planet who's a real geek who's gone to a FOSDEM PGP signing party in order to shake hands with people. And that's quite valuable information. So we do not want to build up a big web of trust even with indirect degrees of separation. On the reputation side of things, totally separately to cross-signing though, we are looking at doing stuff like this in a privacy-preserving manner, using pseudonyms rather than real users, and using per-room pseudonyms so that you get a different MXID for every conversation you're in. And so if somebody is a complete jackass in a given room, that particular MXID might be marked down, but it doesn't necessarily correlate to their activity elsewhere. And you basically kind of have a fuzzy grey list web of trust of sorts, which is anonymized like that, which is sufficient to allow you to do community analysis to say, hey, that guy's a complete jackass and hangs out with a lot of other jackasses, and I'm going to stick a pin in the middle of the jackass cluster and I'm going to mute it. And that is not quite trust, but a similar-ish different answer to a different question.
Okay, thank you, Matthew. I think you can reach Matthew on Matrix easily. So, and ask other questions to him. Thank you very much for a very interesting presentation.
Thanks, everybody.
And